We're so glad that everyone's here today. We have some gentlemen in the room from Pulse Industries, as well as the founder, Dr. Eric Burgett, has so graciously decided to come out and speak to us today. He's a distinguished nuclear engineer with degrees from the Georgia Institute of Technology, including a BS, MS, and PhD in nuclear engineering, mechanical engineering, and human and machine software engineering. His multidisciplinary expertise spans nuclear engineering, radiation safety, material science, nanotechnology, electrical engineering, and software engineering. With over 25 years of experience in radiation technology, Dr. Burgett founded Pulse Industries in 2018 following his successful oversight of a $74 million food treatment facility on the U.S.-Mexico border. His leadership in professional organizations is extensive, having served as the National Technical Chair for the American Nuclear Society, Technology Director for the Health Physics Society Accelerator Section ANS Chair, Accelerator Section HPS Chair, and President of both the Atlanta Chapter and the Health Physics Society and the Atlanta Chapter of the American Nuclear Society. He has received multiple awards for groundbreaking technology and research papers from both the American Nuclear Society and Health Physics Society. Dr. Burgett's technical mastery includes licensed hot cell operations of manufacture of industrial electron linear accelerators, electrical accelerators, and ion accelerators for R&D applications. He has developed specialized instrumentation packages for intense radiation environments. His doctoral research revolutionized the detection technologies for high-dose radiation harsh environments, creating new detector materials and developing both software and hardware measurement systems. This work significantly advanced detector efficiency, imaging capabilities, and spectroscopic capabilities for novel detector materials with direct applications in homeland security and nuclear fuel testing. Almost done. We're very impressed to have him here with us today. His expertise extends to industrial systems optimization, where his doctoral minor focused on computer software and hardware solutions for major logistics operations, including FedEx and Atlanta Hartsfield-Jackson International Airport. His innovations in graphical interfaces and database integration notably improved operation efficiencies for these enterprises. Throughout his career, Dr. Burgett has held positions at premier national engineering and security laboratories, including Los Alamos National Labs, Idaho National Labs, and Lawrence Livermore National Labs. And if you don't know, those are our very important national labs for nuclear weapons. They do a lot of that research there too. His academic contributions include professorships at Georgia Institute of Technology, Idaho State University, University of Maryland, and other institutions. As a principal investigator and project leader, he has successfully overseen more than $57 million in R&D projects and authored over 200 journal articles, presentations, and patents. He is currently licensed as an accelerator manufacturer, accelerator installation professional, and radiation safety professional in Florida, Mississippi, Tennessee, and Texas. And he leads a specialized team of engineers that he's brought some with him today in construction, installation, and commissioning of operational training of industrial electron linear accelerator systems. His recent achievement includes licensure as a master technical reference with UL, further solidifies his position as leading authority in radiation technology and accelerator systems. And we are so lucky to have his company here in Jackson County. And with that, I'll let you take it away.
Thank you. That was the very long-winded version. So thank you all for having me today. I am Dr. Eric Burgett with Pulse Industries. For those of you who don't know who we are down the street in one of the I think that general direction, something over. We're over by the airport. And we just we're in the process of moving from one manufacturing center to another. We outgrew the one we were in, so we're now upgrading to the former Catalyst building. So I'll start by asking, does anyone know that they've interacted with something that was either modified or has used radiation today? How many of you drove in a car here? Okay. The tires on that car were made with a process today, which is vulcanization, where we actually use radiation out of a similar type of accelerator to cross-link the rubber products to make vulcanized rubber. How about who here ate a mango, a guava, pineapple in the last week? Okay, most likely you actually ate a product that was treated with a source of ionizing radiation. So what do we do at Pulse Industries? We are pretty much the United States' only industrial electron linear accelerator manufacturer. In 2018, we were building onesies, twosies of these machines to install at various locations, and one of the big ones is for what we call a phytosanitary application, where we're treating produce as it crosses from foreign countries into the United States to eliminate foodborne pathogens, whether that's things that have 4 legs, 8 legs, 16 legs, 100 legs. We don't want any fruit flies. We don't want boring seed weevils. We don't want things that could risk our crops in the United States. And so we're, after installing a facility there, we were asked if we could also make machines for other various applications. So we went off and started Pulse Industries and began to vertically integrate the operation. We moved it from, I'm not a physicist, I'm an engineer. So I actually solve problems, not just dream up stuff and write it on a whiteboard. That's a joke at my Lawrence Livermore National Lab physics friends, because they normally just sit back and wait on one of us to come in and actually fix their machines for them. But one of the biggest uses that we use for one of our sister companies, so Pulse Industries is kind of overarching. It supports 4 main business verticals. One's for food, one's for treating medical devices, one's for cleaning water, and one's for treating oil. So in food, again, we want to stop pests from coming into the United States. So who's here heard of like Dutch elm disease? Okay, Dutch elm disease is a problem. Killed off a ton of North Americans' elm products. That was because a tulip bulb had a type of fungus on it, was brought into the United States, and that then contaminated the American elm, and we lost, I think it was like 90-some% of the elm trees in the United States. This technology allows that to no longer happen. So we're able to treat food by using our accelerators. So we take standard industrial electric 3-phase power. We use that to accelerate electrons to roughly 99.998% the speed of light. We then shower that onto the product. And it's just like light. When we turn the switch on, it's on. When we turn the switch off, it's off. It leaves no residue. It leaves no contaminants. It literally just makes fresh air. But what we're doing is we're effectively neutering any kind of bug that may be on or in pallets of pomegranates, mangoes, asparagus, strawberries, anything coming in from overseas that a carrier pest or a pest that likes to eat that product. We're trying to neuter it so it cannot reproduce. We don't kill it. We don't have to. We just don't want it to make any more baby bugs. As a result of this treatment, we also provide a shelf life extension capability. So it pauses the maturation process of the harvested product. What this allows farmers and growers to do is that they can harvest later in the season, giving them a higher yield out of their fields per hectare. And it also allows that product to be on the vine longer, giving you a sweeter, more flavorful product. Because right now, the way our entire food chain system is set up, they will harvest things exceptionally green 3, 4, 5 weeks before you would normally harvest it if you were growing it in your own garden. And then they ship it with things like bananas in the same shipment, just so that it emits ethylene gas and causes everything in it to ripen on the way to the store shelves, which is why your tomatoes in your garden taste a lot better than tomatoes that you buy from Winn-Dixie or grocery outlet. Our technology allows it to be treated in the growing region, so that it can maximize the shelf life to get it to you, the end consumer. You can experience anything from like, how many days do people normally get on strawberries? 7 days, 4 days in the fridge before they turn all nasty and rotten? Yeah, we can get about 21 to the 35 extra days on strawberries after harvest before they're going to mold or start to fall apart. So, ones that are regulatorily required, anything from the mango family, anything from the citrus family, as they come into the United States, they all are required by law to be treated with a technology like this. Those two in particular do not do well with cold. They don't like being cold. They will freeze and fall apart. Radiation is a very common modality. So there are a number of existing technology providers down in Mexico, and we're aiming to replace them because they use radioactive waste material as their source of radiation. Ours, we use nice green electricity. So here's a few examples. So the bottom one here is asparagus. So 36 days of difference between they were treated, that's treated, this is untreated. And we ran numerous control studies. We actually entrained and empaneled certified tasters. Miss Angel here was a certified taster for us for a while. So 18 days, you can see strawberries, 48 days on blackberries and blueberries. Those were actually Georgia blueberries grown not too far from here. Same thing with 48 days of mushrooms. Not that I like mushrooms. That was actually a 1-year-old potato. It survived quite amazingly. The next business vertical is Pulse Sterile or Pulse Medical. So anybody have any idea how they sterilize medical devices prior to being used in the hospital? Right now, there are two main modalities. One is cobalt-60. It's generated in nuclear reactors. It's the same thing that BN Beyond uses for food. And the other one is ethylene oxide. I don't know if anybody paid attention. Right before COVID, there was a giant problem with ethylene oxide, and it's still a problem to this day. So what happened was ethylene oxide was found to be a class 1 carcinogenic gas. And what they would do is they'd put medical devices into a chamber, they'd evacuate the air out, they'd backfill it with ethylene oxide, and they'd proceed to do this numerous times inside this gas chamber for days on end. And then they would pull it out and exhaust all of that to the roof. And what remained in the products, they would then sit into a room and allow it to off-gas for several days. The EPA actually, every 6 years, goes around and does a nationwide study on cancers and toxins and pollutants across the country. And they started to find that in 2018, there was a giant problem with ethylene oxide surrounding these medical device sterilizing operations. So they came in and start shutting them down. This one was right outside of Atlanta. Sterigenics was outside of Chicago. And so all of a sudden in 2018, we start having a medical device shortage across the country. Surgeries started being canceled. People were not able to get clean, sterile medical devices. And there really wasn't a good solution except if you could bring more ionizing radiation online. So to this day, it's still a gigantic problem. So what do we do at under Pulse Medical? So we're opening a facility here in Jackson County, and we're also opening one in Elgin, Illinois. It's the suburb of Chicago, but we're going to be treating medical devices. Our technology allows us to be directly comparable in the ability to kill all these viruses and bacteria that may be on medical surgical instruments, gauze pads, Band-Aids, a number of different items that you would see in a clinic or a hospital. We can treat them with our beams. So again, what we do is, this one's a box level conveyance. So every individual package comes by, it gets the light shined on it, and we track box by box that we've delivered that dose to every package, and then we can ship them out. And make sure that they get to operating rooms around the country. The one that's garnered the most attention recently, who here has heard of PFAS and PFOA? PFAS in drinking water? Okay. PFAS has been labeled by the EPA as what we call forever chemical. I guarantee you have run into it in your lives. If you've ever cooked dinner on a Teflon cooking pan, Teflon coated pan, if you've ever sat on a couch that had Scotch Guard, okay, that thing that your parents had on the couch to make sure that when you'd spill your Kool-Aid, it wouldn't stain the couch. Those are all variants of PFAS. So PFAS is a perfluoral oxalic sulfone. It's a really big, long carbon chain backbone, fluorines dangling all over it. One side's hydrophilic, one side's hydrophobic, and the other big use of this material today is in firefighting foam. So airports, Navy bases, Air Force bases, and no, we don't have any of those floating around our area at all. So the problem is that this chemical, we've been using it since about the 20s, and they just recently figured out it's really, really toxic. And just about everybody's got some in it, some of it in you, and there is no way to get rid of it. So as of today, there is no at-scale capability to destroy this chemical. So, and the reason is that the carbon-fluorine bond is exceptionally hard to break. So, pulse wastewater or pulse water, we treat anything from municipal wastewater, industrial process water, environmental leachate, organic chemicals, toxic metals, particularly the PFAS and the PFOAs. As of 2024, during the last administration, they passed a new Clean Water Drinking Act standard that says that clean water will no longer have more than 2.0 parts per trillion of one of those chemicals. And they get, if they're above 0.2, they get monitored. If they're above 0.4, they start getting fined. The problem is that today, in just about any drinking water source, I can sadly probably open this bottle of water up, and I'm going to be able to find at least 1 part per trillion of PFAS because it's in the plastic, it's in the dyes that make the little lids, and it's going to be a forever problem. PFAS. One of the things that we do well, though, is that our beam is considered an advanced oxidative process. So chemistry-wise, who's heard of oxidation reduction reactions? I was going to say your chemistry teacher in the back is going to start flogging all of you. So in oxidation reduction reactions, you always look at what that oxidation or reduction potential happens to be. Well, there are several electron volts is normally how they measure them. So this thing will take over that thing's reaction. Our beam, we start at 10 million electron volts. So we've got the big hammer. And with the big hammer, we can start breaking these carbon-fluorine bonds and reacting these things off and mineralizing them and turning them into a salt that we can use for other beneficial applications, like making electric vehicle batteries, like making additives for making better plastics. So our accelerator-based wastewater system, what we do is it's a modular system. We can package it up, put it on site, and do things like for environmental leachate, groundwater that's percolating through waste landfills. We can actually, they already have wells surrounding them now. We can take that water, treat it, destroy all the chemicals, and make it so that it's a lot safer and removing these chemicals from the earth, as opposed to just moving them around the ecosystem. So a couple of examples. This happens to be a sample test that we ran. So this was untreated water coming out of your wastewater treatment plant. Not this one, it was another one in a different area. That's untreated water. You've got what they consider going through its standard aerobic and anaerobic digestion, and then just plain chlorinated. and then this picture really doesn't do it justice, but that was E-beam treated water, where we're actually breaking down all of the constituents that were still left in the water, destroying things like hormones and actual drugs that still happen to be in your municipal wastewater before it would get returned to a surface aquifer like a river, lake, or stream, or the Gulf in this area of Florida's case. So we're an augmented technology. We add the capability to do a lot better for the earth. This was the treatment system. It was actually deployed down in Miami-Dade County on Virginia Key. They demonstrated its capability to treat, I think it was like 10,000 gallons a day. And at that time, they didn't have a manufacturer of machines that could turn out enough to actually make it a significant and viable solution. This happens to be the new regulation for PFOS and PFOA, according to the Clean Water Drinking Act standard. So yeah, you're not allowed to have any PFOS in the new standards that have come out. So this is going to be a grand challenge. The United States has put laws in place. They must start to understand the problem by 2027. You know, standard government timelines, they're stupidly long. Understand if you sample and understand if you have a problem by 2027, and by 2029 you actually have to start meeting these numbers. That may seem like a very short amount of time for people that are, you know, getting your college degree, but in government time that's like, you know, overnight for them because they're a bureaucracy and they move slow. That happens to be what we call Shrinkov radiation. The beam actually treating water produces this beautiful blue glow. So we do have over 100 publications on the validity of this, and we're now, as of Friday, we've been selected for a program for treating environmental leachate in Virginia. So we're going to be deploying one of our units up there, which is big news for us. So to do all of this, we had to build a manufacturing center. And this is really where I think I was going to spend most of my time today, was telling you about what we do here in Marianna. So as a manufacturer, we build all of the parts to this. And so we've got everything from machinists, CNC code writers, we've got electrical engineering, we've got mechanical engineering, material science, welding, fabricating. So believe it or not, there's actually a very high-tech company right down the street. And as we grow, we're going to be looking to come and work with Chipola College to set up curricula to actually make more and better engineers and technicians for running these machines. I apologize, that one's out of place. We also do a sludge treatment for activated sludge coming out of wastewater treatment plants. There's another set of machines running doing more wastewater treatment. Pulse Petroleum. This one, we just signed a partnering agreement with a group down in Panama. Not Panama City, but actually the country of Panama, on the Panama Canal on the Pacific side. And we're going to be providing value-add services by treating oil to modify heavy sour oil to make it light sweet oil. And so that one's still probably 2 or 3 years off, but there's actually going to be a petroleum and chemical engineering group that we're going to be deploying down there. What it does, by being able to control how we break these bonds, we're going to react off the sulfur and be able to provide complex refinery capabilities with a very limited set of input parameters from our machines. So back to manufacturing, the part that I didn't want to spend most of my time talking about. So what do? We design and build, the very long name for it is a collinear resonantly coupled standing wave electron linear accelerator. So we use RF power that we generate through a series of solid state modules and vacuum tube amplifiers to make a very, very big electromagnetic wave. We run in the S band. So in RF engineering, S band is either 2.86 gigahertz or 2.99 gigahertz. There are two bands that are specifically selected by the FCC so we don't step on top of Wi-Fi and we don't step on top of your telephone or your television sets. They're for science and industry. So what we do is with our power units, we put power into these things here. These are actual LINAC or linear accelerator cups. We match their frequencies so that they're tuned to one specific wavelength or one specific frequency at a given temperature. So who here's had at least EMAG? You guys got EMAG? Physics EMAG? Okay, so did you get into like antenna tuning? No? Okay. So in electronics and magnetism part of physics, what we're doing is we're injecting what we call a standing wave. So we make a resonant cavity where it peaks and valleys at very specific spots inside this copper structure. This is what they look like when they get all stacked up. After we get them to demonstrate that they're all on the same frequency, then we braze them together in a giant hydrogen brazing furnace. All that stuff comes together through various mills, lathes, entire production operation. We also make electromagnets to confine the beam, and we steer the beam with more electromagnets. This is all done we wind copper wire, again, EMAG. So if you wrap a current around a central axis, you produce a magnetic field according to the right-hand rule. I don't know how many parts of my day I sit around with my pencil doing right-hand rule. I flash the right-hand rule like it's a gang sign. So what we do is we machine all these parts. We go through an extensive QA/QC testing procedure with what we call a coordinate measurement tool. And we actually dimension everything, make sure it's all precise according to ISO 9001 standards. And we start to assemble them and braze them together into a big cavity structure. To support that, we've got things like, this is my old electrical or electronics technician, Daniel. We use a lot of industrial power, so he's in his full arc-over, flash-over protection suit. And right before he was to energize that 400-horse motor, we had the giant cane to pull him away if it went bad. So to further illustrate this, this is what we call a pillbox resonator. So it's a resonating cone, and then we have a nose tip, and we actually produce an electric field with that RF wave that we're injecting into this between these 2 points. The electrons get injected and go up the page, and what they do is right about here, it starts to see that this is electrons being negatively charged. This is going to develop a negative charge on it, and that's going to be positive. So it's going to rapidly start accelerating every time it goes through one of these little pillbox resonators from one step to the next. So the electrons, as we inject them into it, they're riding that wave like a surfer rides a wave, and it gets going faster and faster and faster and faster until we start fighting relativity. You guys do know what the general theory of relativity is, right? E equals mc squared. Okay, so nothing can go faster than the speed of light. But as I get closer and closer to the speed of light, we've got this term called beta. Beta being 1, you're traveling at the speed of light. So you get above about 0.9 beta, and I start pushing against the wall. It takes me more and more. I'm not really going much faster, but I'm gaining momentum. And that energy, being that a particle has a rest mass, I've got momentum. Each time they keep going a little bit more, a little bit more, a little bit more until we get to 10 MeV. We stay below 10 MeV because there's a thing called a photoneutron production cross-section that turns on. It's a quantum physics thing. The electron would have enough energy to actually slide its way into the nucleus with its de Broglie wavelength, and we don't want that. That's bad because then we're going to make, if we kick out neutrons, things become radioactive, and we don't want that. We want it to just be light. So, and I was making the joke earlier, you guys have a wonderful periodic table of elements. We have the table of the isotopes. So for every element, you have multiple options between the number of neutrons and protons that are inside the nucleus of every one of those elements. and some of them are much more finicky than others. So things that we do at our facility, we build both X-ray machines and E-beam machines. So X-ray machines, most commonly where you would run into them in your normal everyday life is if you happen to have a sick family member that might have been diagnosed with cancer. They would use a very similar system for treating their cancer using what they call IMRT radiation therapy. We build machines for treating boxes, whether that's a box of produce, whether that's a box of medical devices, really doesn't matter. They do move they're the most efficient because direct E-beam treatment is fast. X-ray treatment, we stay below 7.5 MeV because that's what the law says that we'll do. But X-ray, the problem is that to make X-rays are actually known as Bremsstrahlung radiation or braking radiation. So it's when an electron travels real close to a nucleus and slows down and kicks off X-rays. But it's only about 9% efficient. So we like things in the E-beam mode, and that's where we spend a lot of our time. We do have a couple of clients that like X-rays, mostly Gateway America, and they're pretty much the only ones that are going to get one of those. So things that, as opposed to just selling a machine, we actually go and integrate with or operate ourselves existing company infrastructure. So we integrate and manufacture now our own conveyance systems, our own chiller systems. So this involves everything from technicians, welders, people who run the spray paint booth. Actually, in the first slide, you saw Jeremy sporting a high pressure, low volume spray paint gun. You were in that one. That was you decked out painting conveyor belt. But we do everything, including radiation detection for monitoring what kind of produce is going through. We integrate with USDA, APHIS, we integrate with FDA, and provide them all of the data that they currently don't get from any other service provider. So we're at an interesting time. A lot of people say, well, you know, these have been around since the 70s. Why hasn't it really taken off? This used to be the world of just people who have PhDs and went to, you know, study at Jefferson Lab or Fermi Lab, and you know, it was real difficult. There was no real connection back to like making more engineers, more technicians that would go off and use this technology. They were also very, very capitally expensive and took forever to get them built. We're trying to systematically change all of that. So we're looking at how do we come out, work with future students here on coming up with curricula that we can get you people to have access to the technology to be able to, you know, see that there is a giant impact and how this can change the world. For those of you who like computer games, we do a lot of computer simulations, writing our own software. We do use ANSYS and COMSOL multiphysics now. We're mostly a SolidWorks shop, so I don't know if anybody in here proficient in AutoCAD, SolidWorks. So radiation transport wise, we use MCMP 6 or X or Géant if you know, the French need hits. We also use Poisson Superfish for our particle in a cell and accelerator simulations, and LT Spice for our circuitry designs. We do write our own software again, so this is actually a box tracking system where we're imaging where the beam is and where the beam isn't. And then full graphical interface on top of that that tells you what the status of all of the subsystems that drive our machines are reading. Manufacturing wise, we are of course going to have needs for future machinists to come in, and you know, the kind of people that we're looking to work with or bring on are people that get a holistic picture. So when we actually machine things, we machine them at a very tight temperature tolerance because thermal expansion coefficient of metals is a thing. And literally you can actually cause this thing to change its resonant frequency by about 3 megahertz just by putting your hands on it and warming it up to your body temperature from a standard, 12C lab temperature. We also do a lot of our own integrated circuit design and fabrication now. This is what one of these machines looks like when they're done. Those are big solenoid magnets that wrap around the center of that copper cavity, the copper cavity being right there. That's the gun end. So we have a dispenser cathode electron gun that injects the electrons into the cavity. But we do a lot of pulse power electronics. So anybody that's got electrical engineering acumen, we of course would be interested. There's some solenoid magnets. So these are how we actually steer the beam. Solenoid magnets are what we call a 1D magnet. So all it does is we're imparting, because we've got current going round and round and round in a circle, we're making, of course, the right-hand rule. So we're translating angular momentum into circular momentum. These guys here ended up forming what we call a window frame quadrupole. So that's a third order magnet. And the ones on the right are a dipole magnet, and that's a second order magnet. So dipoles steer left and right, quadrupoles focus like a football. We shoot the beam into a big vacuum chamber called a horn. That's a horn. They're always trapezoidal in shape because we've got to be able to bend them from a central dipole magnet. Does that do what I think it does? It does, yay. So we put a dipole magnet here. It sweeps the beam. If that magnet is off, it goes straight. Otherwise, we sweep the beam left and right. And the reason we make it that wide is so that we can put all the product on the conveyor underneath of that horn. When we go to install them, this is a view from above. We use lasers to focus everything because literally when the beam comes out of the machine, it's 800 microns in diameter. We have to blow that up to about 18 centimeters across when it comes down. And this was a specialty horn. It actually split the beam into 2 beams, and there were 2 conveyors under this one. So as far as RF engineering and manufacturing, things like reflow ball grid arrays, power electronics, FPGAs, ASICs, we've got needs for all of this stuff to be designed in-house, and we're looking to be growing programs for these. As far as high-speed computing, the guys literally just put together our second high-performance computing cluster. So that's now online and is getting programmed as we speak. Power electronics, we do a lot of high-power power electronics. When we pulse the LINAC, it's actually drawing 5.5 megawatts during the pulse. So it's a pretty spicy meatball. And then as far as control electronics, we are a UL certified panel shop now, so we can build all of our own custom control electronics, variable frequency drives, and other stuff that goes along with it. So we're to be done and relocated by August. And we're looking at trying to come up with ways that we can work more with the port in Panama City to be able to enable more commerce trade into the United States for fresh produce. We're also looking at opening up facilities in Savannah and a couple other locations. And we are looking at, over the next 5 years, we're going to be adding 100 new jobs to the market. So that's why one of the reasons we're here today is to, one, show you that there are cool science things in this town, that finish your degrees and come talk to us, because we're going to be hiring all kinds of different engineers and technicians and scientists. Everything from people who do molecular biology, single cell biology, fuzzy animal biology, entomology, and then all of the engineerings. We're also going to be working on workforce development with the VOTEC programs around here for welding, machining, and sponsoring then educational programs to encourage people to grow with us as we grow. And we do have pretty decent at this point, considering we really got off the ground running about 3 years ago. COVID kind of kicked us all in the cojones. But here, we're looking to open a food facility in Savannah. We've got a food facility that we're opening this summer in McAllen, Texas. 2 food facilities, one in Veracruz and one in Michoacan. We've got a medical device facility we're opening October of next year in Puebla, Mexico. And then a medical facility in Elgin, Illinois, as well as our new environmental leachate program that will be first sited in Bethel, Virginia. This is kind of what our systems, it's novel in that we don't require you to build this fancy pants building. We actually take and we'll retrofit and install these into Sealand cargo containers. That way they're easily shipped and deployed. And that's a real game changer because it used to take 2-3 years to install one of these, and now we can do it in about 35 days. All right, so with that, I'll leave it open if you guys have any questions about what we do, or if you just want your QR code. I know how it is. I sat through many of these. Total, 10.5. I got faster as I went. So it was 5-3-2. So 5 years for my bachelor's, 3 years and 2 years. But I was different. I had a full-time job. I was authoring papers. I was doing things during I graduated with my undergraduate. I had 5 publications and 2 patents. So I was a full-time hot cell operator at the time. So I was running, Wiley Labs was feeding us a lot of product at that time. So, I mean, we were running the hot cell 6-7 days a week. I was in there running the hot cell, irradiating anything that went into, so anything that flew on the STS missions when we still had the actual Endeavour spaceship, the things that it would put up into space, we tested all of them and irradiated all of them to give them their entire cosmic ray dose spectrum in 2 days. That way they could determine, is it going to survive in space? And then we did a bunch of nuclear reactor pressure valves and all kinds of other stuff. Honestly, bachelor's degree is a great starting point. Okay, master's degrees are nice if you know exactly what you want to do, but I would encourage people, get done with your bachelor's degree, even if you're an associate's degree and you just want to, go get your feet wet for a while, go work for a company, get an understanding, because a lot of times what will happen is that company, if they like what you're doing, if they're a good company, they're going to have a training program. They'll pay you to go back to school to get your master's. What is the long-term goal for Pulse? So the long-term goal is we're going to continue to manufacture these and open. We need, right now, based on demand, we need probably 10 food facilities in just the United States. We're going to be putting in 23 food facilities in Mexico. Medical device facilities, we probably need 20 or 30, and that's going to be in North America, probably Ireland, Puerto Rico. Or we want to put these co-located near where things are being manufactured. And some of that's going to change with politics that I don't like talking about, and so I'm not going to. But as things move around, we're going to be mobile with that need. As far as the water side, that's really what our long-term growth model is, we're tackling what I consider humanitarian challenges. How do you feed more people with fixed amount of resources? How do you give more people clean drinking water and access to clean drinking water? It's through our technology. How do we make sure that people have clean medical devices? Okay, we're removing things that cause cancer, and we're using things that we can power with renewable energy or clean nuclear powered energy, however we get that energy, but it leaves no residue, does not cause cancer. So when you're talking about waste landfills, there are something like 1,000. It depends. The numbers are all over the place, but active landfills, you've got hundreds and hundreds of active landfills. Each one of them every day is leaking PFAS back into our drinking water streams. Just filtering it out of the drinking water does not. All you're doing is kicking the can down the road for another generation. Okay, until you destroy it, you're not removing it from the ecosystem. So that's where we want to be the solution, that we're going to clean drinking water, we're going to clean food, we're going to clean medical devices. And so, our goal is to get the factory up to the ability to make 150 to 200 linear accelerators a year. That means that we can open, 20, 30 plants a year. We're going to be making machines for a long time.
How long do the machines last?
They have surprisingly very few moving parts. So they're like I've run 45-year-old machines before. They last a long time. It's not like a car engine that's going to go bad. There are consumable parts, just like with anything. So that the dispenser cathode's kind of like a light bulb. Eventually the light bulb burns out, you got to screw a new light bulb in. But right now we're telling people it's 25 years before a major overhaul.
So down the road, this will be a more effective and cost-efficient way of like purifying water rather than the standard practices of today.
Yes.
What kind of physicists do you guys work with, and what do they do for you?
So we work with everything from solid state physics and particle physics personnel. So solid state, we use a lot of IGBTs, insulated gate bipolar transistors. They're the main switch mode power supply component that we use a lot of. And then the quantum mechanics versions, they're beam optics and particle interactions. How do we optimize the lineal energy transfer spectrum for a given product? And they also have the ability to do the radiation modeling for radiation damage, radiation chemistry, et cetera.
So you were talking about like different engineering jobs out of what level of degree would you want to see your employees at, like AA, bachelor's, master's?
Me personally, and my ethos, I would like to see associates and bachelor's level students coming out of programs, because I want to teach you, and then if it's a good fit, I'm going to pay for you to go back and get a master's degree in something that's very specific, because this is a very small community of people that do this. So they'll, like, if you're in EE, you're not probably going to go, I'd send you to probably, he's at Kennesaw State now, he was at UNC Charlotte, but I'd send you to very specific people that I know have curricula that, and I would probably, for your advanced degrees, be sponsoring your master's thesis anyway. Any other questions?
You guys do internships?
We do. We'll be opening up around probably, end of May? Yeah, we'll probably have them towards the end of summer, and then going forward, we'll have, depending on what your school schedules are.
Unfortunately, we are in the middle of a move. It's just right across the street, but when you have a big building with lots of big moving pieces, it's going to take us a few months just to get everything over there. And once we are in our new location is when everything will really start to take off.
How many interns do you take, or like what's the application process?
She's going to run the application process, and I don't know, probably 5 or 6 in a quorum.
We're starting to go through all that right now. Right now, like I said, since we're moving buildings, kind of our focus is on that. Once we get that up and running, we are going to be majorly hiring. So we have lots of opportunities that we're going to be putting out. Like you were saying before, this is a multidisciplinary manufacturing plant. So if you're thinking this is just for scientists or engineers, it's not really. there's many moving parts are incorporated into a plant like this. Everything from data entry to nuclear engineers and everything almost in between. So any kind of specialties that you have, be on the lookout, because as we're going to hire people, we want to see people with multidisciplinary resumes, different courses, different classes, different jobs that you guys will have. So,
Do you think there's any possibility for internships for this summer?
I'm not sure of any
senior year?
internships this summer. Hold tight on that. Like I said, we're just kind of starting our new Q4 figures for the summer and stuff like that. Because
Check back in at like late
this
May.
is very all-encompassing right now. So it's
We
really
literally are having to uproot the entire manufacturing center and move it down the street. So
it's just like right now, that's our main focus. So we will be hiring. There will be lots of internships. On our website is where we're going to be posting. We have I'm gonna call it not jobs corner, but like an employment center. It's gonna be it's already posted right now because we did have 2 jobs we're hiring for, but those are closed already, and they're for electrical engineers and other high level things. So like I said, keep checking back on the website. I would say drop by, but it's a little difficult to do that right now. Once we get back up and running at full capacity, then we'll definitely have way more opportunities for stuff.
Did you have anything else you wanted to share with?
no,
Yeah, and y'all can still stay and ask questions if that's okay with you.
perfect.
But for those of you that want to get your, I just hate paper. I want everything electronic. So it's been quite a challenge for me coming here because everything is like old fashioned.
Heck, even people that, because of our customers, if you happen to speak Spanish,
Oh yeah, you're a Spanish speaker like right now?
that would definitely get you an internship real quick.
And if you are technical Spanish speaker, like meaning like scientific words and such.
That would be a good opportunity.
Yeah, I may be